The only constant in nature is change, and therein lies much of its beauty. In the flutter of wing beats, or in the tangled web of life that over the centuries creates a forest. In the shadowy stillness, it is hard to imagine that in its youth, this place was once a wind-torn beach. But it was, until tamed by a force more irresistible than the wind. The power of life itself, as plants and animals first conquer, then transform the land. This happens so slowly, it's difficult to recognize, but there are places where the land itself is changing. Waves swallow it in great angry bites, only to build it anew, virgin land for life to claim. The complete transformation from bare sand to tall forest can take as long as 6 centuries, a blink of geologic time, but spanning many human lifetimes. There are few places where this change can be read from the landscape as from a diary. One of these is Presque. The Great Lakes lie along the border between Canada and the United States. They were scoured out by glaciers during the ice ages. On the southern coast of Lake Erie, a rock shelf 12 miles long lies 30 feet beneath the waves. The prevailing currents from the west have picked up sand left behind by the glaciers and piled it onto the shelf, creating a curved sand spit. For perhaps 1,000 years, Presque has been driven eastward along this shelf at an average rate of 17 yards a year, half a mile each century. Wind and wave have been removing sand from its neck, sometimes breaking its connection to the mainland, only to deposit it at the growing eastern tip. But when severe storms come crashing out of the north, they reshape the tip, hooking it southward. Over the centuries, this process has been repeated many times, building a series of ridges separated by lagoons and ponds. Upon these narrow strips of land, one of nature's great dramas unfolds, as animals and plants first colonize the beach and then gradually transform loose sand into lush forest. This dynamic process is called succession. It begins on the most recent spit of shifting sand, newborn land, piled here by the lake in the last storm. This latest outpost doesn't seem to hold much promise, but poised just inches above the lake's surface, it is the blank canvas upon which life will paint its image. The incredible power of storm-driven waves can sculpt a hook in a single night, but the sand is carried here to Gull Point by a more gradual process. Prevailing westerly breezes push waves against the shore at an angle. With every gentle lap, they push the sand grains just a few more inches east. The grains are deposited in tiny ridges, building new land where there was once water. The immediate shoreline is still part of the lake, cool and moist and teeming with life. But above the water's reach, it's a virtual desert, scorched in summer, frozen in winter, and always scoured by the wind. The surface grains are constantly on the move. Life can hardly gain a foothold in the bare sand, except where death leads the way. A fish stranded by the waves and driftwood piled high by the storm contain a treasure trove of nutrients locked within their skeletons. And protected from the sun and wind beneath these gifts from the lake lives the advance guard of the animal community, an army of mites and springtails which feed upon the flotsam, turning it into compost. Springtails live up to their name. If danger threatens, their evasive leaps are quicker than the eye. The tiny creatures convert driftwood into droppings, beginning the conversion of sand into life-sustaining soil. Beneath the larger pieces of driftwood, unlikely beach dwellers wait out the heat of the day in cool, damp recesses. In the last rays of light, Fowler's toads wake to a very appropriate pursuit for a warm spring night. They have gathered here to spawn in the shallow pool behind the sandbar. The toads fill the darkness with the sounds of courtship. Having attracted a female with his song, the male mounts and holds her securely. Together, they hop to the freshwater pool to lay and fertilize the eggs. Just a few days later, uncounted thousands of tadpoles hatch. They develop rapidly in the warm, shallow water. There, they feed on the remains of plants washed in from the lake, seldom resting in their search for food. After 4 weeks as tadpoles, they change into miniature toads. Now they must leave the water. But for some, their first steps onto dry land are also their last. Following the dictates of their internal clocks, this unlucky brood continues its assault upon the beach, even though most are mummified in a hail of sand grains whipped up by the wind. These shifting sands are as inhospitable as the harshest desert. But even deserts support life. And within a few months, the first hardy invaders appear. Russian thistle actually thrives in these conditions. It's a plant of sand plain and desert. To fight the desiccating effects of wind and sun, its leaves are fleshy and covered with a thick, waxy cuticle. Bands of purple pigment protect its tissues against ultraviolet light, while long roots anchor it firmly in the loose sand. Very few plants can survive here, a dozen pioneer species at most, all brought in as seeds by the same forces that built the beach, wind and wave. Seaside spurge is one that doesn't have deep roots. Instead, it hugs the ground to avoid the wind. Its leaves are small and waxy to minimize evaporation, and its stems are purple, like those of the thistle. Successful as they are, these annual herbs and grasses are not permanent residents here, for among them is a species that will cause the sandbar they're living on to change forever. These are not ephemeral herbs, but the tough seedlings of the cottonwood, an extraordinary tree with the power to dramatically alter its environment. They have all the necessary adaptations of desert plants: deep roots, waxy leaves, reddish stems, even the ability to survive being buried alive. As their stems are buried, they sprout roots, securely anchoring themselves and the dune on which they grow. Cottonwoods do another unusual thing. They grow in neat rows. They germinate only in the damp, bare soil along the shores of young lagoons, and each row traces an old high water mark. This compact wall of tiny trees acts as a windbreak. As the sand piles up, it stimulates the growth of new roots, building the ridges that characterize Presque Isle. Eventually, the dunes spill over into the ponds. Some become sand plains, others marshes or wooded swamps, while the deepest remain lagoons. Meanwhile, the constantly shifting dunes are invaded by a specialist. American beach grass can survive drought and wind and spreads out over the bare sand by means of runners. But its most telling adaptations are its roots. Like the cottonwood, beach grass grows as rapidly as it is buried and puts out roots from its covered stems. They branch into finer and finer networks, entangling each tiny grain. In this way, beach grass and the cottonwoods not only create the dunes, but hold them in place. Once the restless movement of the sand is stopped, plants rapidly cover the whole face of the dune. As we travel west towards the middle of Presque Isle, we pass over a progressively older landscape. Protected from the wind by the dunes and cottonwoods, the sand plains between them are invaded by herbs and grasses. The hairy puccoon could never have survived on the windswept lakeside, but here, in the tangle of meadow-like vegetation, it finds a home. It gets its name from the covering of fine silvery hairs on its leaves, a protection against the fierce sun. By their very existence, these plants change the conditions in which they live. Some, like the lupin, add more nitrogen to the sand than they take up. So gradually, year by year, the barren sand is transformed into soil. By the time the land is 7 years old, it is sufficiently rich and moist to support shrubs. The toughest of these new invaders is the bayberry, hardy, slow-growing, and equipped with virtually inedible leaves. They're covered with indigestible waxy granules and laced with poisonous chemicals. As a result, its only enemies are a few species of moth, whose caterpillars have evolved immunity to the bayberry's poisons. This one creates a shelter from 2 leaves by sewing them together with silk from its mandibles. Once it's secure inside its living tent, it literally eats its way out of house and home. It chews away at the green tissues from within, leaving the veins and the waxy granules untouched. The loss of a few leaves is no setback to the bayberry. In 10 years, the seedlings have grown into sturdy bushes, shading out the herbs and grasses and creating the conditions for a richer and more diverse shrubland community. Leopard frogs take advantage of the moister habitat and the new opportunities for food and shelter. The shrubland becomes a riot of vegetation, locked in competition for light and space. By now, the cottonwoods have developed into a sturdy windbreak, providing shelter for a variety of more delicate flowers. Instead of the wind, these plants rely on insects to pollinate them, a partnership that has created a wealth of diversity and natural beauty. In more open areas, prairie grasses flourish, their flowers nodding in the breeze that spreads both their pollen and their seeds. Without shelter from the wind, such delicate forms of life would be blown away. At ground level, the matted stems and grasses provide home and highway for the vole. This secretive and prolific rodent needs a dense cover of vegetation, both for food and for protection from predators. The shrubs above the vole's hidden runways provide a whole new level for animals to colonize. Yellow warblers find the fertile shrubland perfect for raising their brood of hungry young. One of some 10 bird species that lives here, the warblers need the sturdy bushes to nest in and the abundance of insect life as food for their young. But while the male warbler sings from the branches of a 40-year-old cottonwood, his shrubland community is under attack. It's being invaded by the new wave of life that will transform it into forest. The seedlings of cherry, maple, and oak. It will take more than a century for these seedlings to shade out the shrubs and replace them with a dense stand of mature trees. The climax in the gradual succession of barren lakeside into verdant forest. The canopy is an unbroken patchwork of oak, maple, hemlock, and ash. The dappled light that penetrates the canopy is intercepted by the leaves of understory trees. Little light manages to reach the forest floor, a damp and somber place of thin grasses, ferns, and fungi. It is also the nursery of the forest itself, where the seedlings of these great trees take root and grow. They live in the patchwork of light and shade on the forest floor, their growth suppressed by the dense umbrella of leaves above. But when an old tree dies, letting light flood in, they are ready and waiting for the race towards the canopy. And so the forest is continually renewed, a self-sustaining community of plants and animals, every one adapted to its niche, every commodity utilized to the full, a channeling of energy from sunlight through plants to herbivores, and on up the food chain to predators. Foxes range the whole length of Presque Isle, from the water's edge to the heart of the forest. The bright sand outside their den is a reminder that this woodland ridge was once an ancient dune, a dune that was formed centuries ago. Before that, it was just a sandbar beneath the waves of Lake Erie. Here at Presque Isle, the miraculous is commonplace, tracing the pageant of life on this gift of sand from the lake. But what the lake has given up, it can just as easily take back. Between the ridges that were once dunes, fingers of water reach into the very heart of the peninsula, creating ponds and wetlands of great richness and beauty. As the lake level fluctuates naturally over the years, the land between the ridges changes gradually from dry to wet and back again. High lake levels turn back the successional clock by killing the trees. Their rotting hulks are a reminder of drier decades. The water is an agent of both creation and destruction. The lake first built the land on which these cottonwoods grew, only to reclaim it later. It also plays a vital role in the dispersal of their seeds. mid-June, and countless billions of seeds cascade like snowflakes from the cottonwoods. Despite their superabundance, all but a few hundred will go to waste. Cottonwood seeds will germinate only at the water's edge on moist, bare soil, totally free from the competition of other plants. On Presque Isle, these conditions are found behind the newly created sandbars at the growing tip of the peninsula. This row of waterlogged seeds will change these bare sands into a tapestry of plant and animal life in a mere blink of geological time, creating on this slowly moving peninsula a dynamic, evolving series of changing habitats. This outpost of land and life moves through both space and time. The continual birth and colonization of new land makes Presque Isle a rare and wonderful place to discover the ecology of succession. Sadly, though, ecology cuts little ice with the other forces at work here, forces unwilling to accommodate the rhythms of nature. The 1,000-year journey of Presque Isle may soon be coming to an end. For 10 centuries, Presque Isle has been molded by the tireless forces of nature. Now, human hands are reaching to take control of its destiny. Presque Isle is a Pennsylvania state park and plays host to millions of visitors each year. They crowd onto the beaches, the best beaches remaining on Lake Erie's south shore. Most visitors are unaware that they share this moving peninsula with a fragile and constantly changing community of plants and animals, whose very future may soon be placed at risk. The killdeer's distraction display may divert attention away from its precious eggs, but it cannot protect these shifting sands. State park managers have a difficult mandate to somehow balance the interests of conservation and tourism. There's no easy answer. Against the odds, the killdeer may succeed in raising its brood on a beach that must double as a nest site and playground. But further inland, the ecological fabric of the peninsula is itself under threat. The forest, which took hundreds of years to mature, is being eaten alive by a growing population of white-tailed deer. In the shrubland, they destroy almost everything except the poisonous bayberry and the exotic Japanese honeysuckle, disrupting the natural balance between plant species. In the forest, their love of fresh new leaves is stunting the growth of most of the young trees, bringing regeneration to a halt. If their numbers are not controlled, there will be no new trees to replace the old ones, and eventually the forest will disappear. Another threat to Presque Isle comes from Lake Erie itself. Exotic kinds of aquatic life from around the world have hitched rides here in the hulls of the tankers that ply the Great Lakes. Once here, they can seriously threaten local species. And the Great Lakes have been fraught with serious pollution problems for decades. The city of Erie has grown prosperous on income from the bayfront and on the millions of dollars spent here each year by visitors to Presque Isle. In fact, without this arc of sand and forest, Erie would never have been founded. It was the peninsula's shape, not its unique ecology, that attracted people in the first place. French settlers built a fort here in 1753, attracted by what they described as the finest natural harbor in the world. They called it Presque, almost an island. In the War of 1812, Commodore Perry built his fleet here. He was blockaded by the British forces, but protected from them by the peninsula's treacherous sandbars. Later, he escaped into Lake Erie and defeated the British Navy in a famous battle that changed the course of the war. The natural harbor of Presque Isle Bay continued to dominate the fortunes of Erie City throughout the 1800s. By the close of the century, Erie was a bustling rail terminal and port, handling vast quantities of iron ore and coal. But storms sometimes smash through the neck, exposing the bay to the prevailing currents. Each time, the Army Corps of Engineers tried to repair the damage, using pilings or even planting thousands of saplings along the sandbanks. But the lake always seemed to gain the upper hand. By the early 1900s, the peninsula had become more than a giant breakwater to protect the bay. It was a playground for the people of Pennsylvania, and the battle to preserve the perimeter of Presque Isle took on a new dimension. But whatever the engineers constructed, the waves sooner or later destroyed. In essence, the engineers were trying to combat the forces that had been moving Presque Isle along the shore for 1,000 years. Their resources and technology simply were not up to the task. For 100 years, they built all manner of devices: fences, sand traps, breakwaters. The lake claimed them all. In the 30s and 40s, a determined effort was made to stabilize the neck once and for all, with a massive seawall of boulders and steel. The cost was some $3.5 million tax dollars, and it took the Army Corps 20 years to complete the task. These extreme measures secured the neck, but destroyed the beaches, and severe storm damage in the early 50s caused the engineers to think again. In the mid-50s, 6 million tons of sand were dredged out of the Presque Isle marshes, pumped over the neck, and used to rebuild the peninsula's beaches. The cost of this massive operation came to another $2.5 million. To the waters of Lake Erie, this giant gift of sand was no more than a mouthful. Winter storms tore into the beaches, sweeping the sand along the perimeter of Presque Isle to deposit some of it at the growing tip, while the rest disappeared into deep water. The tattered remains of breakwaters and groins emerged from the sand once again to remind the engineers of the futility of fighting the lake. From 1959 onwards, sand has been added to the beaches to replace the quantity removed each year by the storms. Called beach nourishment, this effort has involved some 200,000 tons a year at an average cost of $1.5 million. Beach nourishment is a more gentle approach than the hard stabilization of groins and breakwaters. Rather than attempting to defeat the forces of wind and water, it uses them by simply feeding sand onto the conveyor belt of the lakeshore currents. Each truckload may remain on the shore for a year or so, but sooner or later, the storms carry it away. The system worked reasonably well, but faced with the financial burden of placing sand on the beaches indefinitely, the Corps of Engineers once again sought a permanent solution to the problem of beach erosion. They devised a scheme to build the largest system of breakwaters ever constructed, an experimental and highly controversial design. In 1978, the Army Corps of Engineers selected an eroded beach on Presque Isle as a test for their scheme. The longshore current here carries sand to the east, where it will accumulate at Gull Point. The Army Corps built 3 experimental stone breakwaters to absorb some of the impact of the waves, reducing their erosive force. With less wave action, the longshore current slowed, depositing the sand it was carrying between the shore and the breakwaters. In a little more than 10 years, they became attached to the growing land. Without doubt, the breakwaters were helping to rebuild these beaches. But further along the shore, erosion actually increased as the nourishing supply of sand was cut off. By 1988, the lake had taken a huge bite out of the shoreline, and there was nothing to replace it. Nevertheless, the Army Corps judged the experiment a success, and the full-scale operation was planned in detail. Their plan was to build a perforated wall of stone along the entire shoreline, 58 gigantic rubble mound breakwaters, each one 50 yards long, about 100 yards off the beach, and 120 yards apart. If the breakwaters perform as hoped, the beaches should no longer be battered and eroded by seasonal storms. And the annual chore of clearing up sand driven onto the roads should become a fading memory. Whatever the theoretical benefits, The scheme has been criticized by engineers, geologists, and environmentalists alike as an ill-conceived experiment.
Most of us believe that the state really does not appreciate the difficulty of managing this breakwater system over time, that the Corps has not really studied the situation enough to know, and because of the experimental nature, we can't possibly know how much manipulation of sand, how much dredging of sand behind these breakwaters is going to have to be done, how much manipulation of these beaches will have to be done to make the systems work as they properly should.
Even with the breakwaters, the Army Corps of Engineers concedes that continued beach nourishment will be necessary, as well as dredging behind the mounds of stone. And the view out over the lake will be transformed. Instead of a natural vista of waves and sky, the great piles of rock will obscure the horizon. When lake levels fall again, as they surely will, the breakwaters will protrude 8 feet above the water. More serious are the concerns about the quality of the water.
I think that the amount of pollution that could be expected to increase as a result of quieter, stiller waters is going to be a continuing problem for the park. And we already have a beach contamination problem to a minor extent. And until we solve the problem of that, having the breakwater projects is going to increase this problem.
The fear is that contaminated water will be trapped between the breakwaters and the shore. And there's another concern about the safety of swimmers.
I think that the breakwater project is going to cause a safety problem. I think kids are going to want to swim out to the rocks, explore, and they will be hurt. I think there are dangerous currents that are likely to occur as a result of the construction of these breakwaters, and these currents could sweep away children.
These fears are based upon the tragic consequences of similar breakwater schemes.
In Pinellas County in Florida, 5 people have drowned at a county park there. This park is protected by a breakwater structure. The opponents of the breakwater structure in Pinellas County say that these drownings are directly attributable to the breakwaters, and probably they are.
The Army Corps of Engineers feels it has taken all these points into consideration at Presque Isle.
We discussed the safety aspects of the breakwaters at length for a number of years. We have watched in other areas where breakwaters have been installed, and we have watched the prototypes, and to our knowledge, there hasn't been a safety problem. There are always times when people will try to get on the structures, but the lifeguards have been able to whistle them off, and it's no worse. I don't believe it's any worse than having groins. The groins have been there for 35 years, in some areas probably 50, and I don't believe the safety aspect has been that severe.
There is also concern about the effect the breakwaters will have on Gull Point.
An additional problem with the breakwater is that although they work very well to defend the beaches immediately behind the structure, these kinds of structures always have an end effect, and the end effect in this case will be Gull Point, which is a very valuable bird sanctuary.
In fact, with its supply of sand choked off by the breakwaters, Gull Point may begin to wash away. And with no new land being formed at the eastern end, all the successional habitats between sandbar and forest could disappear, changing the whole nature of the peninsula. The cost of the controversial scheme to protect the beaches will be high. Estimates for financing the construction, maintenance, and continual beach nourishment spread over the projected 50-year lifespan of the breakwaters are in the region of $3 million every year. But is there a viable alternative?
The alternative to hard stabilization at Presque, the alternatives to building breakwaters at Presque would be to use sand. A sand nourishment program has been used somewhat successfully here for the last decade and has prevented large-scale erosion at Presque. It's the alternative of choice along the Atlantic shoreline where hard stabilization is prohibited by law. The sand is available here. The problem is that it's a continuing program, one that the Corps would have to get involved in year after year. It is expensive, but would not have any of the harmful side effects that the breakwaters have. What we'd be doing is using sand to replace the natural sources that have been cut off for years by hard stabilization to the west. If the sand is there, beaches form, the beaches provide that kind of stabilization that's required without the side effects.
The very best protection for a beach is the beach itself, as long as sand continues to be transported there, either by nature or man. Because of the side effects of breakwaters, at least 3 states have made their construction illegal. And there's another attraction to the idea of continuing beach nourishment alone. It costs approximately half the amount projected for the breakwater scheme, 1.5 as opposed to 3 million tax dollars per year. But the argument is not that simple.
Presque Isle is a very dynamic system, and Mother Nature wants to erase it. It's a protrusion in an area or a reach of shoreline that's very straight, or generally very straight, and the erosion is very severe on Presque Isle. We have a limited supply of sand, and we figure that there must be a compromise where we can have usable beaches for the several million people who use Presque Isle, for them to use and still have a reasonable cost of keeping the peninsula here. Since it is a very dynamic system, it's going to be a challenge, an engineering challenge, and it's going to be very expensive as long as we try to hold Presque Isle in the present state.
The challenge of holding Presque Isle in its present state, or rather in its present position, has preoccupied the Army Corps of Engineers for almost 2 centuries now, but with mixed results. After fighting the lake for so long, the prospect of a final victory is enormously appealing. But will the beaches that draw so many millions to Presque Isle become polluted, unsightly, perhaps even dangerous to unwary swimmers? And will the unique variety of habitats found on Presque Isle disappear, as many predict they will? Only time will tell. It's difficult enough to manage Presque Isle as both an ecological preserve and a magnet for tourism without considering its wandering ways. And we are only just beginning to learn how to manage a successional system where continual change, not constancy, is the natural course. Without some sort of human intervention, the peninsula will continue its slow journey eastward until it gradually erodes away into deeper water. In the autumn of '89, the Army Corps put in the first 3 of the 58 planned breakwaters before bad weather hampered construction, an indication perhaps of the battles ahead. The controversy being fought over this 7-mile spit of sand has relevance far beyond its shores. Beaches, sand spits, and barrier islands everywhere are tremendously valued, and everywhere the problem is the same. By its very nature, a beach is land in motion. To still this movement is always costly, not only in tax dollars, but in the health and diversity of the natural world. Perhaps we would be more successful if we tried to work with nature rather than tilt against the windmill of her might.